Okay, this is the Chapter 16 exam review, our last chapter for this class. And before we get into most of the exam question types, I just want to take a quick minute here to talk about what most of this exam will be over, which will be the time value of money. And here's a little quick take on it, basically. There's three types of cash flows that we've talked about in this chapter. First is a lump sum. You're getting one lump sum sometime between time zero, which is now, and all the way up to whenever the actual problem ends. So sometime you're getting one lump sum of money, or you're getting a set of equal payments, and that's called an annuity. And these equal payments go throughout the life of this situation, whatever that is. Or the other possibility is you're getting irregular payments, which we'll discuss later in detail, but basically every year the amount is different, and that requires a separate type of thinking about that. So now, the four tables that we've talked about in this chapter will take care of solving how to solve these problems with respect to the time value of money. And by the way, the time value of money, in a nutshell, is you're trying to decide on a situation where you're getting money either now or sometime in the future, and what you're trying to decide is what's the better alternative. And the best way to do that is to use what's called the discounted cash flow method, which basically says if you have to wait to get the money, that is, if you have to wait to get the money, then that has a value, and that value usually is the interest rate at the time that the transaction takes place. And these tables we're going to talk about deal with how to solve that problem, how to put everything on an equal footing. Now, lump sums, there's two ways to handle those. And the tables that we're going to look at are two different tables here. The PV, or present value of an amount, is equal to the future value times the table value based on a certain period, which is in this case a number of years or a number of months. Usually it's a number of years, and a certain interest rate. Another way to look at lump sum is with a second table, which is called the future value of an amount. And that future value of the amount is equal to the present value times the table value based on a certain number of periods at a certain interest rate. Both of these tables deal with lump sum, and both of these tables, you might say, are reciprocal of each other. You could find the same answer going about the problem by using, it would be the same, you'd use two different tables, but you could find the same answer. All right, another situation is an annuity where you have equal payments. And in that, the other two tables would be the present value of an annuity is equal to the periodic payment, which is, I just mean that, by that I mean the equal payment you're getting each of these accounting periods or each of these years. And that's multiplied times a table value. These tables are like 5, 6 places, and they're in the back of most financial books, most accounting books, and they're in the back of your book, or let's say online. Anyway, it's table value based on a certain number of periods at a certain interest rate. That's the present value of an annuity. And then the future value of an annuity, that is something where you're going to be getting this somewhere out in the future, you would multiply this periodic payment times, again, some table value that the problem gives you, which is based on a certain number of periods and a certain interest rate. So with that said, we're going to work some of these problems. Now, how do you solve these? You answer these two questions. First of all, you have to understand when you read the problem, what is the type of cash flow we're dealing with? Are we dealing with a lump sum? Or are we dealing with an equal set of payments? And if it's a lump sum, you're going to use one of these two tables up the top here, the present value of the amount or the future value of an amount. If the cash flow is a set of equal payments, then you're going to use these other two tables, which would be the present value of an annuity or the future value of the annuity. And then what we're really going to be doing here is we're going to be doing a situation where which of the four formula parts do we have? This is the unknown, and usually, notice all these formulas, there's four pieces to them. There's a present value, in this case, a present value of an amount, a future value, a number of periods, and an interest rate. That's 4 pieces. Each of these table formulas have 4 pieces. You'll be given 3 of them, and you're trying to find the 4th unknown piece. Okay, let's take a look at our first problem. What amount of cash must be invested today in order to have $35,000 at the end of 1 year, assuming that the rate of interest is 8%. So they want you to use either the present value of a lump sum. This is expressed as $1. So the present value of the lump sum, or the present value of an annuity of $1. So you have to ask the question, are we dealing here with a lump sum situation, or are we dealing here with a series of equal payments? And the way the problem reads, how much cash must you invest today in order to earn this, have this $35,000 in 1 year from now? That's a lump sum. So now the only question is, what do we know and what do we not know? Well, we know the future value, which is $35,000, but we don't know the present value, which is the amount you got to invest today. And we do know the interest rate is 8%, and we know the time period is 1 period or 1 year. So let's take our table, present value of an amount, lump sum that is, and let's plug in what we've got given to us. So the net present value is what we're looking for. We're trying to find the expected cash flow, which in this case is that $35,000. And the present value factor will be the 1 period at 8%. So when we look all this up in our table, $35,000 times that table value that represents, again, 1 period at 8% will be 0.925926, or the amount you have to invest today if you're going to earn 8% for 1 year to get $35,000 after 1 year is $32,407. And again, that's based on 1 period at 8% interest. Next problem. What amount of cash would result at the end of 1 year if $14,000 is invested today at the rate of return of 12%? And so we know that we're dealing with one lump sum here. There's no equal payments mentioned in this problem. So we're going to use the present value of $1 or the present value of a lump sum table value. So here's our table. We'll lay it out like this. The net present value is equal to the expected cash flow times the present value factor. And the way this one is stated, if we invest $14,000 today, that means we know the net present value, that's $14,000. What we don't know is the amount that we'll have in the future, which is this expected cash flow. But we know it's going to be at 12%, and it's going to be for 1 period. So let's plug in what we know and solve for the rest of it. So $14,000 is equal to the expected cash flow, which is we don't know, times 0.892857. That's the present value, table value you're going to get when you look up 1 period, 1 year, 1 period at 12%. And so when you do all that, you take the 14,000 and now you're going to divide that by the 0.892857, and you'll get that future amount is going to be $15,680. Another way to say this is to say that if I put $14,000 in the bank today and I can get a 12% interest rate, and now you put it in there for 1 year, I'll end up with $15,680. Let's take a look at our next problem. Dewey thinks he can get $180,000 cash per year for 5 years on a real estate investment project. So already we're dealing with a series of equal payments. In this case, it's for 5 years, $180,000 a year. If Dewey wants to earn a rate of return of 12%, what is the maximum that he should pay for this investment? And they want you to use either the present value of a $1, which is lump sum, or the present value of an annuity. And so since this is a series of equal payments we're talking about, we're going to use the present value of an annuity table. So let's put this down. So the net present value, which is what we don't know, and is how much should we invest today, is equal to the expected cash flow, and that's going to be, in this case, that $180,000 a year for 5 years, times a present value factor based on 5 periods at 12% interest. And we're going to look up a table value for that, in the present value of an annuity table, and that's going to be 180 times that table value, 3.604776, or we should, and it's going to be $648,860. So if we put $648,860 in this investment today, in today's dollars, we should get back, if we can earn 12% on it for 5 years in a row, we should get back $180,000 each year from this investment. Now, this problem was the present value of an annuity. You could have had a present value, or excuse me, the future value of an annuity problem. And the way you can tell the difference is you would set both of these little tables up. Net present value equals the expected cash flow times the present value factor. You would do that for both sets of tables, that is the present value table and also the future value table. And you'd have to ask the question, what formula would I use if I'm trying to find a formula where I know 2 of the 3 pieces? And this is the only formula that'll work for you for these equal periodic payments, because that sentence, right, let's see, where does it say it at? Right here. It says, what's the maximum that he should pay for this investment? And you should assume that that's right now in today's dollars. How much should he pay right now for this investment? And right now means the present value. And so the present value of the annuity is what we're going to use, that present value table, not the future value, because it would say something like, how much would he expect to get 5 years from now? But that didn't say that. It said, how much should he pay right now? So that's how you know this is the present value of an annuity as opposed to the future value of an annuity table that you're going to use. Okay, our next problem is another annuity problem, but we're looking for a little something different here. Dewey has $580,000 to invest, and it should say to invest right now in a 5-year annuity. Assuming that the time value of money is 12%, what amount will Dewey receive in cash each year? So the unknown here is this equal periodic payment, and we are going to use the present value of an annuity table, and we're going to plug in the pieces we know and solve for what we don't know. So the net present value, we already know that, with $580,000. What we don't know is this expected cash flow each year. I used to call this the equal periodic payment, and I still do, and that's going to be the unknown. The present value factor will be based on the present value of an annuity table, which is going to be 12%, and that's going to be for 5 years. So let's plug all that in. And so $580,000 is equal to this expected cash flow each year, which again we don't know, but it's the present value factor, or the table value, is 3.604776. Now when we divide that present value table factor into the $580,000, we're going to end up with what the expected cash flow is each year, which is the equal periodic payment, which is $160,898. Okay, our next problem, and no one should better miss this one. Assuming equal time intervals between payments and a constant rate of return, which of the following cash flow patterns represents an annuity? Well, I've been telling you that an annuity is a set of equal payments. And so, looks like to me, $1,360 every year for 6 years. That looks like equal payments to me. B, you get $1,040 in the first year, nothing the second year, third, fourth, and fifth year you get the same amount, and then the sixth year you get nothing. So it's equal payments, but not every single year. And then the third one looks like it's different payments every year. So the answer to this is, understanding what the definition of an annuity is, which is a series of equal cash flows. The answer would be A. Okay, our next question. XYZ Company has 2 investment opportunities. Both investments cost $5,000 and will provide the following net cash flows. So investment A gives you $3,500 each year for 4 years. Investment B gives you $3,500, $4,600, $2,500, and $1,200. Now, what is the net present value of investments A's cash flow, assuming 8% minimum return. So what you're supposed to do in this is ignore B altogether. Why they gave you that information is beyond me. But you're going to take each year and you're going to figure out what the net cash flow is for these cash flow payments, discounted all the way back to the present. And the way you're going to do that is with the present value of an annuity table. So you're going to take the present value, and that's what we're looking here is the present value of an annuity, which is going to be the periodic payment, which is $3,500, times the table value based on 4 periods at 8% interest, which is what the 8% return was. And then when we get that number, we're going to subtract it from the cost of the investment, which is $5,000. And if it's a positive number, it's going to be a positive net present value. If it's a negative number, it's going to be a negative net present value. So let's do that. So net present value equals, like I said, the net present value is going to be the present value of the cash inflows of these $3,500 payments using that present value of annuity table minus the cost of investment. So we're going to have $3,500 each year for 5 years, or 4 years rather, will give us a table value based on 4 periods at 8% of 3.312127. That number is going to give you, subtracted from $5,000, is going to give you what the net present value is. And let's see, did I do that? Okay, so I just set up here, just stressing this idea that net present value is equal to the cash inflows, which in this case would be $3,500 times 3.3121217 minus the cash outflows. You're going to pay for this investment $5,000. And anything else here? Whoops, let me go back to that. So let me put this in my calculator here so I can give you that number. I should have done that earlier. $3,500 times 3.312127. That equals $11,592 to the nearest dollar here. So you're going to get $11,592, and the investment's going to cost you $5,000. Should you do that? Well, yes, you should do that because it gives you a positive net present value. And any time in these problems where it's a positive net present value, that's a go situation. Okay, our next question. XYZ company has 2 investment opportunities, just like the last one. Both investments cost $6,100 and will provide the same total future cash inflows. So you can see that investment A, you get a total cash inflow at the end of 4 years of $10,530. Investment B, you get the same total of $10,530. And the cash receipt schedule for each is shown below. And they want to know what is the net present value of investment B, that's this one, right, B over here, assuming an 8% minimum rate of return. So what you're going to have to do, since these are uneven cash flows, I said I'd mention that from the very first part of the review, each one of these cash flows is going to have to be discounted back to the present. That is, you're going to have to take the present value, for example, for this first cash flow, $1,550, you'll have to use the present value of an amount, because we don't have equal cash flows here, but the present value of an amount times 1 period times 8%. The second one will be times the table value based on 2 periods at 8%, 3 periods at 8%, for the next one, 4 periods at 8%, and then take all those together, add them all together, and then that will be the total value of all those cash flows, and they'll all be discounted to times 0, which is, today's dollars. And then you'll compare that to the $6,100 to see if it's a go or a no-go. So let's do that. So the net present value equals the expected cash flows times the present value factor minus the cost of investment. So the net present value, again, we're going to have to use the present value based on 1, 2, 3, and 4 periods respectively at 8%. So the first one, like I said, that's the $1,550 times that table value. And then the second one, 2660 times the table value that's for 2 periods at 8%. And the next one is for 3 periods. That's the table value representing 3 periods at 8%. And you can see that these present value numbers, as you go further out in the future, they're worth less money. These cash numbers are worth less money because you have to wait longer to get your money. And then finally, the fourth one, 2550 times 0.73, so on and so forth. Add them all together and subtract them from $6,100, and the net present value of this investment B is going to be a positive 2483. So you should go ahead and do that because it's a net present value that's a positive number. All right, our next question. An investment that cost $30,500 will produce annual cash flows of $10,170 for a period of 4 years. So you're dealing with equal periodic payments. And it says if the investment costs $30,500, you have to assume that that's a present number. That's a present value number, which means you're going to use the present value of an annuity, not the future value of an annuity, and definitely not a lump sum. And so you're going to put these table of numbers in here, like so. The net present value, which we know is $30,500. And let's see, the annual cash flows, you know that also, which is going to be $10,170. And it says, given a desired rate of return of 8%, what will the investment generate? All right, let's see what we got here. So you've got $10,170. That's the equal periodic payment each year for 4 years. And the present value of 4 years, which is going to be a table value of 4 years at 8%, will be 3.312127. And that equal cash flow number total, and let's see what that comes out to be. Well, we know it's going to come out to be $3,300 and looks like $684. So it is a higher number than what you have to pay out. So if your investment costs less than what you're getting back in cash flows, it's a go, because in this case, the net present value is a positive number of $3,184. Okay, in this problem, Dewey Company is considering purchasing a capital investment that is expected to provide annual cash inflows of $16,900 per year for 3 years. So we're dealing with a series of equal payments. Assuming that Dewey's required rate of return is 6%, so we know the interest rate is 6%, and we know the number of periods is 3 periods or 3 years. What is the present value of these cash flows? So we're looking for the present value of what those cash flows are. So we'll use the present value of an annuity table, plug that in, and we'll know we've got here expected cash flow, $16,900, times the table value in that present value annuity table based on 6% for 3 periods is 2.673012, and the present value of those cash flows are going to equal $45,174. So they never did ask us, we didn't have any idea what they actually were going to spend on this, but they just want to know what the present value of those cash flows were. Our next problem. An investment that costs $25,500 will produce annual cash flows of $5,100 for a period of 6 years. So we're dealing with a series of equal payments. Further, the investment has an expected salvage value of $3,050. That means that at the end of the 6-year period, we can sell this investment and get back $3,050, which is another cash flow that's coming back to us. So we've got $5,100 every year for 6 years, and at the end of 6 years, we've got a $3,050 cash flow. So we're going to compare all those cash flows that are coming in, including the salvage value, with the cash flow going out, which is the cost of this investment, which is $25,500, and see exactly if we have a positive or a negative net present value. So let's do that. So net present value is equal to the expected cash flows times the present value factor minus the cost of investment. And we've got expected cash flows are going to be $5,100 times a table value based on the present value of an annuity, which will be based on 6 periods at 12%, which is 4.111407. And we're going to add to that another cash flow that's going to come back to us, which is selling this investment at the end of its life for $3,050. And this will be the present value of a lump sum. Don't mess this up on the test, because we're now switching back over to a lump sum type situation. So if we're going to get this $3,050 in the future, that is 6 years in the future, we want to know what the present value of it is in today's dollars. And to do that, you take the present value of an amount. And that table will be based on 6 periods at 12%, which is 0.506631 times $3,050. These two cash flows will be added together and then subtracted off from the cost of our investment. And the cost of our investment was $25,500. And when you do that, you have to trust my math on this, but when you do that, you get a negative net present value of $2,987. So you would have to say, no, this is not a good situation. I don't think I want to do this, because it's a negative net present value. Now, I thought I would piggyback off this question and give you the same exact numbers here, down below here. The only difference is going to be we're not going to have a salvage value. And this really is much easier. This is what we've been doing before. So if you didn't have a salvage value, you do the same exact thing. Oh, by the way, that I just told you from those tables were based on table 2, number of periods and interest rate, so forth, so on. And so now, if we do the same exact problem, and this time we don't have a salvage value situation, then we'll use the same formula. And we'll plug in the same things that we know before, right? This is the same problem, no salvage, but it's really easier. So this time we're going to have the 5,100 equal period, equal cash flows coming in for the same number of times, periods, which would be 6 periods at 12%. So 5,100 times 4.111407 minus 25.5. And since we don't have another cash flow coming back to us, that means we're going to be even worse off. This time our net present value is an even larger minus number, which is a negative $4,532. So you could see one with a cash flow and one without a cash flow on the test. Might even see both, who knows? Okay, our next problem, XYZ company has 2 investment opportunities. A cash flow schedule for the investments is provided below. We have investment A. You're going to spend $5,000 and you're going to get equal cash flows for 4 years of $2,000 apiece. Or you could look at investment B, which you're going to spend $6,000 cash outflow, but you're going to get back $3,000, $2,000, and $1,000 each year for 4 years. Considering the unequal investments, what's the best technique to choose the most appropriate investment, A or B? Well, the technique that you should use for getting when you have 2 different kinds of investments here and you're comparing apples to oranges, you should use something called the present value index. And the present value index is, and that's the answer right there, that you should use the present value index. The present value index, it takes the present value of the cash flow inflows and divides it by the present value of the cash outflows and gets a number. And that number gives you, which, and the higher the number is the one you should pick. So the higher index number indicates the better alternative and higher rates of return. And let's see. Now, that's the answer, and that's all we had to go. That's all we had. We could stop right there. But I want to go just a little bit further, just to show you one little thing here. Notice now the present value index is going to be the present value of the cash inflows divided by the present value of the cash outflows. Well, the present value of the cash outflows, that's $5,000 for investment A and $6,000 for investment B. So if we wanted to try to come up with this present value index to compare these 2 investment alternatives, A and B, you'd have to do this. You'd take investment A, investment B, the present value of the cash inflows divided by the cash outflows, right, for both of them. And you can get the $5,000, like I said, for A, and same thing for B, get the $6,000 for B. But that's where things stop, because you don't have a key ingredient here. You can't come up with the present value of these cash flows, these cash inflows. You've got the number of periods, and you got the amounts, and you know that it's the present value of an annuity. What you don't have is you don't have an interest rate, so you can't go any further. But you didn't have to go any further because that's not the question. What the question wanted. All it wanted was the present value index. That was the technique you're supposed to use. Okay, our next question. An investment that costs $6,500 will produce annual cash flows of $2,900 for a period of 4 years. So every year you're going to get $2,900 if you spend this $6,500 on this investment. Given a desired rate of return of 10%, what is the present value index? Okay, the present value index. So we can figure out what that's going to be by doing the following. First step we want to do is we want to find the net present value of the cash inflows. And that's going to be the expected cash flows every year, which would be $2,900 every year for 4 years. And you're going to take that table factor, which is 4 periods at 10%. So let's plug all that in. So we've got $2,900 times a table value that represents 4 periods at 10%, which is 3.169865, and that means those cash flows are worth $9,193. So if you spend $6,500, you're going to get back in today's dollars $9,193. So now let's turn that information into a present value index number. So the present value index is equal to the present value of the cash inflows, which was this $9,193, divided by the present value of the cash outflows. Well, the cash outflows, the present value of those would be what you paid at time 0 in today, which is $6,500. So let's do that. So $9,193 divided by $6,500, the cash outflow, would give you a present value index of 1.414. Now, higher is better, but you don't have anything to compare it to. They just wanted to see if you could compute this index. Okay, this is our last question. XYZ Company is considering purchasing a capital investment that is expected to provide annual cash inflows of $16,100 per year for 3 years. Assuming that XYZ's required rate of return is 9%, what is the present value of these cash inflows? So they want you to use the present value of an annuity. They give you choices, but you should know by now that if it's a series of equal payments, we're dealing with the present value of an annuity. And then we're going to make the calculation. So let's do that. So the net present value, which is what we're looking for, is equal to the expected cash flows, or the cash flows every year, periodic payment year, which is going to be $16,100 for 3 periods at 9%. So that's going to give you a table value of 2.531295 times $16,100. And the present value of those cash inflows is worth $40,754. And that's what they wanted to know. Now, that you wouldn't want to pay any more than that for this investment, because if you did, it'd be a negative net present value. I believe that's the end of it, except for one more thing. It just tells you that we use table 2, 3 periods for 9% interest. And then last but not least, if you're interested, I have a brother-in-law who lives in Texas, who is on the, he was in on the ground floor. He can get you in on the ground floor of this new invention he's got. It's amazing. It's bound to be $1 billion idea. And like I said, if you're interested, give me a call after class and we'll take this up. Basically, this is an antenna that picks up voices, and it's something that I know a lot of people can use. I think we're going to market this regionally at first and then go national with it. And again, if you have any interest in getting on the ground floor of the stock, just let me know. And by the way, good luck on the test.